Hello everyone, I am Agrihub Jr. and I would like to introduce you challenge number one, further development and testing of the application for creating variable rate application maps. The goal of this challenge was to support further development of web-based application for preparation of variable rate application maps. The application is called Farm Insight. In order to achieve valuable results, we involved the community of users and other stakeholders into the design and testing of the solutions. First, I will introduce the features of Farm Insight application, which already existed before Challenge 1, and then I will proceed to main progress achieved during Challenge 1. But now, let me introduce our team and stakeholders. Our development and management team consisted of me, Wojciech Lukas, Karel Charvát, Dmitry Kožuch, and Herman Šněvajs. Main stakeholders of our challenge are Farm, Zemědělské družstvo Dolní Újezd, and Asahi Breweries. And now let's proceed to the introduction of Farm Insight application. Farm Insight is a web-based application designed for preparation of variable rate application maps. The first version was developed under Horizon 2020 project DataBio, and later the development continued as a part of other projects and as a part of commercial activity of less project služby and cooperating organizations. Before I proceed to the progress made under Agrihub INSPIRE Hackathon 2022 Challenge 1, I will briefly introduce the main features of Farm Insight application. There are many different approaches to preparation of variable rate application maps. The one we originally chose for application Farm Insight is based on relative yield variability within selected fields, and now we are continuing to add more different approaches. The main idea behind preparation of variable rate application maps based on relative yield variability is that the productivity of different parts of the fields often repeats through multiple years. If there is a part of a field where you achieve high yields compared to the average of the field 1 year, there is a good chance there will be high yields next year too, and vice versa. If there is a part of field with relatively low yields, there is a good chance in the next season there will be low yields too. If the meteorological conditions are somehow untypical or extreme for a given location in some seasons, there might be significant deviations from this behavior, but in long run, the relative distribution of the yields within most fields tends to repeat. The colored zones you can see in the map represents relative distribution of the yields within selected fields. Here you can see the color scale. So the values range from 40% of the average yield of the given field to 135. It's necessary to mention that these values don't serve to comparing one field to other fields. It is always for comparing the relative yields within the field. The values are not comparable between different fields. The relative variability of the yields is estimated based on satellite data, Landsat 8 and Sentinel-2 using index EVI in growing season through 8 years. For preparation of variable rate application maps, it is usually more suitable to use zones classified to 5 categories or 3 categories instead of this classification to categories by 5%. Once the agronomist of the farm has this data, it's up to them to choose what strategy for variable rate fertilizer application to use. One of the possible approaches can be to support more the parts of the field with higher productivity and put less fertilizer to the part of the field where lower yields are achieved in long run. Now, when we have inserted these parameters of the variable rate application, we are ready to download application map. The calculation of relative distribution of the yields is not fully automatic yet. The process requires consultation between our specialist and the agronomist of the farm and verification of the input data. The typical approach is that the agronomist creates project for his farm, import the fields from publicly available database of land parcel information system, and then order the calculation of this yield variability for selected fields. Here we see the process of creating project for the farm and importing the fields from the publicly available LPs. There are more ways how to get data about fields into the project. In addition to importing the data from LPs database when the project is created, we can turn on the LPs layer and import data for any selected field later. Importing of shapefile or manually drawing the boundaries of the fields is also possible. When the data about the fields are ready, the agronomist of the farm can select fields and order the calculation of yield variability. Now we have 4 fields selected, and then we can place the order. In addition to this relative distribution of the yield within selected fields, we also have a map of relative yield variability for all fields in the arable land in the whole Czech Republic. But these are rough data without manual verifications, so there can be quite a lot of errors, especially in locations where the division of the fields to different crop doesn't correspond to the data. If the agronomists know that the division of the field to crops correspond to the reality, one of the other options how to create the variable rate application maps would be drawing it manually, for example, based on this relative distribution of the yields which we have in this rough form for the whole Czech Republic. But I'm not going to show this because of the time reasons. As I mentioned in the introduction, there are more approaches to preparation of variable rate application maps. More of them can use satellite data. So we decided to use Agrihub INSPIRE Hackathon 2022 as an opportunity to integrate one more approach to application farm insight. The approach we used before Agrihub INSPIRE Hackathon is based on relative long-term yield variability within selected fields. Now we are starting to focus on approaches which are based on monitoring of current crop status. Here we benefit from the tool called FieldCalc developed and tested during Agrihub Inspire Hackathon 2022 Challenge 11. The purpose of this tool is automatic classification of a field using the selected index in the selected date. In addition to the user interface you see on this image, FieldCalc tool offers API and 2 endpoints which we integrated into Farm Insight application. Currently, we use EVI index in the version of FieldCalc tool integrated into Farm Insight application. Using of the tool is very easy. The user select field, choose field calculator, select the date of the satellite scene and the number of zones and run the processing. And here we can see the resulting zones. If the agronomist finds the classification suitable for the field operation he is planning to perform, he would be able to download this data the same way as the application map based on long-term relative yield variability. The technical side of integration of FieldCalc tool into Farm Insight application is relatively simple. We are using the first endpoint of FieldCalc tool to get the list of the available Sentinel-2 scenes for the selected location. Then the geometry of the field is extracted from the field data stored in Farm Insight data model, transformed into GeoJSON, and together with other attributes passed to the second endpoint of FieldCalc application. Then the results are obtained, stored in the Farm Insight application data model, and we use integrated visualization tool to display the result. In addition to successful integration of the tool FieldCalc into the application Farm Insight, we defined several new tasks for further development of Farm Insight application in the cooperation with users and stakeholders. From the points you can see here, the top priority is the integration of field division into automatic calculation of the zones. The main reason is that the preparation of data for the analysis takes relatively a lot of time, and this is a feature that would really speed up the process. This feature was subject of other challenges of Agrihub INSPIRE Hackathon. The integration is already in progress. Thank you for your attention.